Today we will start with membership operators. Now there are two membership operators here. So a membership operator is used for what purpose? It is used for checking whether a particular substring or a character is a part of a larger string or not. Basically it's used with sequences, that is strings, lists, tuples, dictionaries, sets and so on. So here we are just going to see about the membership operator. So we have two membership operators here. 1 second. Oh, I didn't share my screen, right? Did I share? Oh, no, I've shared it. Okay. So we have two membership operators, in and not in. So in is used to check whether a substring is present in a string or not. Substring exists in a string or not, right? And if it exists, then it will give us true, and if it doesn't exist, then it will give us false. And not in is just the opposite, because we are adding the not logical operator over here, which will return true if a particular substring is not present in the string, right? And then we have some comparison operators. This we have already studied in the first chapter. Okay, I had also explained to you how these comparison operators are used for compare to integer values, to float values, and even string values, right? So we will be just discussing that a little more today. So I have opened my Python idle, and now we will be first checking the in and not in operator. So I write here, I take a string and I just name it as a string. Okay. Or let me take a short name and let me take it as st. So we'll just write here. So I've just taken a string named technology, and here I'm just going to check whether O is present in technology or not. So O is one character. I will just write here O in st. Print enter and you see true. Why? Because O is already there within st, and if I write OLO in st, this will also give me true, because we have this OLO as a substring inside technology. But if I just change it and make it OGY, this will also give me true, because we have OGY over here, right? And I was just trying to take any such combination like T, C and N I have taken. This will give me false, because we have these characters separately, but we don't have them in a continuous pattern. Okay, we need to have these characters in a continuous pattern in the form of a substring, that is part of a string. Please note something, that a substring is a part of a string. Okay, so substring is a part of a string, and it is a continuous array of characters. Right? So in and not in are the two operators, and just the opposite will be done by not in. That is, if I just write OLO not in st, what will it give me? False, because OLO is present in st. The operation with in would have given us true, and if I just add not to it, it will give me false. So that is these are the membership operators which can be used with strings. So in this particular chapter, you will be understanding which all operations can you perform on strings and which all operators can you use with strings. Then next we have the comparison operators. Now what are the comparison operators? You already know that these operators are used to compare, to perform string comparisons. To understand string comparisons, it is important for us to understand the ASCII characters, the ASCII values or ordinal numbers associated with the characters, with every individual character which we are working with. So I'll just show you the ASCII table, students. Yes, so just take a look at the ASCII table over here. So I'm just magnifying it. Now what you can see over here is there are certain values given to every character. So here you will find that the first value which is being displayed, that is the decimal value. That is your normal ordinal numbers which we are talking about. Then the second value is the hexadecimal value with base 16, and the third one is the character which has this value. So this is the ASCII table, and every character internally is stored with these ASCII characters. Now the difference in Python is Python stores everything in the form of Unicode characters, which is another coding system, which is a universal coding system, and it involves or it includes all characters of the world, all characters of world languages. But it can also work with ASCII characters. Okay, so if you just want to check the ordinal number related to a character, you will see that it will return the ASCII character. So here, and even in the Unicode table, you will find that ASCII values are also there. Like I'll show you the Unicode table also. Scroll down. So these are all the characters, right? And each of these characters have their decimal values also. So you can just check the decimal value. The first value is something like U plus 0041, and the second value is the decimal value, that is 65, right? So each value, each Unicode character has its Unicode value also and its ASCII value also. So we will just see where the standard ASCII values are. So here you have the characters. So we have to first check the characters. So these all are the non-printable characters. Null, start of heading, start of text, text, end of transmission. These all, the backspace, horizontal tab, line feed, vertical tab, you cannot see these characters. You can only understand that these characters are there by looking at the output. Okay, if there is a significant gap between two lines, it means there is a line feed. So you can understand it by the presence of data around that character, right? So these are non-printable characters. They don't echo on the screen, or they are not displayed in anything. They don't display anything on the screen. Coming to this side, now you can see there is a white space and its its decimal or ASCII value is 32. So space, you can just make a note of these. White space, single white space character has an ASCII value of 32, right? Then you have the special characters, as you can see, and these special characters span from decimal value 33 to 47. As you can see, exclamation mark, double quotation marks, then the hashtag, dollar sign, these all are the special characters, right? Coming down, you have 48 to 57, that is the digits 0 to 9, as it is already specified over here, just above it. So 48 to 57 are the digits. Now these digits are right now, if you are you can represent them in two ways. One is as numbers, that is numeric values, integer, float, complex, boolean, right? In that case, if you are just assigning a variable any value, then this is what an integer value on which you can perform arithmetic operations. But if you are writing something like this, or 50 within quotation marks or double quotation marks. This is what alphanumeric in nature. It is not recognized as a number, rather it is recognized as a string or text on which you can perform concatenation on this. Like if you are writing st1 and st2, st1 is 50 and st2 is 51, and these two are strings, and if you try to do st1 plus st2, what will you get? 50, 51, because this is concatenation, right? But if you take a equals 50, b equals 51, and if you perform a plus b, you will be getting 101, because this is an arithmetic operation. That is sum of two numbers, right? So this is the difference between digits recognized as string and digits recognized as numbers, right? So individual digits have, they start from 48, that is 48 is for 0 and 57 is for the digit 9, as you can see over here. 0, 48, 9, 57, and in between there are all the values which just uh, jump by a factor of 1, right? And then again from 58 onwards, you will again find some special symbols which expand up to only 40, that is till this, till 64, that is till this at the rate symbol. And then you get the capital letters, that is capital alphabet starting from capital A. So the first one is 65 and the last one is 90 over here. This is for capital A to Z, and then again you have some special characters starting from 91, as you can see over here, up to 96 you have special characters, then 97 you have small a, and then 122, that is small z, and then again from 123 to the last you have the special and non-printable character 10. So this is your Ascii table, and this is very, very important, students. Please do download the Ascii table, and what you need to do is just keep this table in mind. So we have this table over here, depending upon which we will be performing some operations using comparison operators. So here you have the comparison operators, less than, greater than. So how does this work over here, right? So let's just, you have to just remember here that these numbers have lower ASCII values as compared to the alphabets, and upper alphabets are smaller in value than the lowercase alphabets. That is, capital letters will have a smaller value than small letter alphabet. So you can see, understand it from the ASCII value. Internally, whatever comparison will be done, it will be done based on the ASCII value or the ordinal numbers, right? So capital A to Z, their values are less than those of small a to z. So whichever string you are comparing, it will be, the comparison would be done in this way. If I have like a string st1, and st1 contains what? Capital A, and st2 contains what? Small a. And if I write st1 equals st2, what answer should it give us? Tell me. Will they both be considered as equal? The answer is false. They are not equal, right? They are two different values, because internally these two have two different values. This has 65 and this has 97 as the value, right? So please remember this. Now I'm taking st1 equals, okay, let me do this directly on the idle now. So just like, let me just reduce its size. So now I am taking st1 equals a string Amit, and how do I to it, I'm just going to use multiple assignment. ST1 is Amit and ST2 is Anand, right? If I write ST1 equals ST2, of course they will not be equal because these two are the number of characters is also different and the individual characters are also different except the first character. Now here ST1, if I write ST1 greater than ST2, what answer should we get over here? You can see that I'm just pressing enter, you get answer false. Let us now just figure out why this is so. So now you have ST1 as Amit and ST2 as Anand, right? So you can see, and what is the operation given here? ST1 greater than ST2. So we will start how Python does this comparison. Python or any other programming language, how it does the comparison. It will first check each of the characters like this. Like I'm writing the characters over here. First check the corresponding first characters. So 0, 1, 2, 3, 4. I have just given some spacing. This is also 0, 1, 2 and 3. So 0 and 0 characters, that is ST1 0 and ST2 0. The zeroth character, that is the first character in both the strings are compared. Are they equal? Yes. If because they are equal, it will do the comparison for the second character of both the strings. Now first one is M and the second one is N. Which one is greater? You know that M, N, O, P. This is the order. Okay. So N always will be having greater ASCII value as compared to M. You don't even need to learn the ASCII codes. You can just understand here. That is, you can just see over here. I'll be looking over here in the small m category. So M, small m has 109 as the ASCII value and small n has 110 as the ASCII value. Now already they are in the ascending in the alphabetical order. Hence the character which appears first, that would be having less ASCII value as compared to the next one. That means M is not greater than N. Rather, this is the condition. Okay. So what was our original operation here? Whether ST1 is greater than ST2 or not. So first one was already eliminated. Now we check the second characters and M is actually less than N. So the result will be M greater than N. It will be false. So it will not check further because over here itself it is proved that the first string is not greater than the second string. So let us just check this. What will I get as the answer? Yes, we are getting the answer false. Let's take another example. So we have this ST1 greater than ST2. What answer are we getting? False. So let's check this. So ST1, we will write them like this. ST1 and ST2. ST1 is 1, 2 and 3. ST2 is 1, 2, 3 and 4. 0, 1, 2 and 3. So ST1, we are checking what? Whether ST1 is greater than ST2 or not. So we start now because they are strings right now. So string comparison will take place. So 1 is equal, 2 is equal. Okay. These two are equal, this is equal, and now we come to the next one. Now ST2 has one extra character than ST1. Hence ST2 will not, ST1 cannot be greater than ST2. It will give us false. What is true? ST2 is greater than ST1 because ST2 contains one more character, right? Let me give you another example over here. So I have two similar looking strings, okay? And what should I get? ST1 less than ST2, I'm writing it now, okay? So it is giving me the answer as true. So let us now first evaluate this one. ST1 is Anjali. I'm writing it like this. This is 0, 1, 2, 3, 4, and 5. And ST2 is Anjana. Now the number of characters is equal, as you can see. This also has 0, 1, 2, 3, 4, 5. That is total of 6 characters. Both of them have 6 characters. Okay, so the number of characters is equal, but that doesn't guarantee that both the strings are equal. Let us now check what was the operation ST1 less than ST2. So we will first check, is A less than A? No, they both are equal. So this is eliminated. N is also equal, eliminated. J is also equal, eliminated. A is also equal, eliminated. Now L. Is L less than N? L, M, N, O, P. This is the order. So L appears first, right? That means L is smaller than N. Hence, this answer will be true.
Ma'am, if the two strings are there and one string has a greater number of characters, but
Hmm.
the string which have smaller number of characters has a ASCII value greater than that string having more number of characters. First one ABD and
Okay.
second one ABCD.
So let's do the comparison. And what is it? Whether ST1 is greater than ST2? Answer is true. So let us just see what is wrong with this. A, B, D. You know, and here we have A, B, C, D. Just pay attention to this one. I'll explain. So ST1 is what? A, B, D, right? And ST2 is A, B, C, D. Number of characters is different over here. And what is the operation? ST1 is greater than ST2, right? So A, B, D, A is same, B is same. D, so C appears first and then D comes, right? So that is the reason why D greater than C is what? 1 second. It is true. D and C. So we are comparing what? ST1 is greater than ST2. So we are writing whether D is greater than C or not. And yes, D comes after C in the ASCII table. 99 and this is 100. So which one is greater? Of course, D is greater. So the answer is true. Got it?
Okay, ma'am. Yes, ma'am.
Okay, so that was about comparison and same we will be working with the others. So I suggest that you people try out all these comparison operators. Less than equal to, we already know either both of them will be equal or less. Okay, and greater than equal to, either both of them will be greater or sorry, both of them would be equal, or one greater than the other. And equal to is already used for checking equality, which we have done a number of times, and not equal to if two strings are not equal or unequal, right? Please note this point. The uppercase letters are considered smaller than lowercase letters. Now, determining ordinal or Unicode value of a single character. So how will you get the ordinal value of a character? So for this, you need to use two functions. One is the odd function and one is the chr function. So what the odd function will do? It will return the ASCII value of a character. And what the chr function will do? It will return the corresponding character denoted by the ordinal value. So let's try them out. So if I want to get the ordinal number of a character, so I will use odd function and I can just give any character over here like G and press enter, and it will give me the ordinal number, that is ASCII value of G. And if I want 4, I'll get the ASCII value of 4, right? Then CHR. So if I just write CHR, I have to, it means I will be able to convert an ordinal number or ASCII value into its corresponding character. Let me just randomly take any value over here. For example, I'll take 128 or 138. What is the actual value? So it is giving me some code, and specifically it is, I think, hexadecimal code. Wait a second. 122. Yes, so it is giving me Z. It has to be within the permissible limits. That's why. Because your ASCII table, it ends at 127. Okay. Hence, 138 is not recognized as a valid character. So let me take anything like 65, and it will give me the character A. If I write here CHR31, it will give me a non-printable character, and you can see this is the non-printable character, that is unit separator. Okay, unit separator means number separator, like 45 comma then 000. If you want to write 45,000, you can use that. Okay, so that's all in today's class related to strings. Now let's get back to our Python control flow. So we have a question here, you can see it. Draw decision tree for grade calculation as per this. So here we have, and let's start with the decision tree. So we have marks and we have grade, right? So first one is marks greater than 90. So I'll write it like this, marks greater than 90. If marks are greater than 90, grade should be A1. That is, if it is yes, then I will simply assign A1 to the grade. And if it is no, we will be checking the second condition. Now it is given greater than 90 and second one is 80 to 90. That is, it should be greater than 80 and less than or equal to 90. Now because the first condition was already false, so this is implied. You don't need to write it. ये false हुआ तभी तो वो दूसरे condition में आया. Means it is obvious, if this condition is false, it is obvious that the marks are not less than equal to 90. They are what? Greater than 80. Okay. So now it would be okay. Next is, if this, now we have to check the second condition, that is marks greater than 80. If this is yes, that means the grade will be what? A2. And if this is no, your grade will be what? You will be checking the next condition, which is 70 to 80. And now it will just proceed in the usual way. You just see, you have to apply your brain only in the first and the second condition. Rest everything starts, it already starts moving on smoothly. Next grade is what? B1. Then no. Then you have the next one, that is 60 to 70. If this is yes, then grade is B2. If this is no, again we will check the condition, that is next 50 to 60, greater than 50. If this is yes, it will be C1. And next, of course, it would be marks greater than 40. If it is yes, grade will be equal to C2. And if it is no, the last one is less than 40 is F. So if marks are not greater than 40, it means they are less than 40. It should actually be, one second, let me just see, greater than 90, and it is 290. Less than, it is already being fulfilled. So no means equal to 40 or less than 40. So grade will be equal to what? F. You can just see that this is forming a type of a ladder. So easily you can just see it it's forming a ladder, a step ladder or a staircase. Okay. And hence what am I going to use in order to fulfill this logic?
If elif else ladder.
Very
If
good.
elif
If
ladder.
wonderful. If elif else ladder. So with this I end today's class.